lovely. The final session of this FUNARCH is Markus. You have to admire the combination of the authors' names on this paper. We've got Markus, Markus, and Marco, just to be really confusing. One of these authors is going to proselytize to us about bidirectional data transformations.
Thank you. Yeah, so I'm the second Markus on this paper. So not the one with a C, but one with a K. So that's our little abstract. You don't have to read that. Before I go right into the talk, I want to draw some attention to this website I'm currently working on. So we have the functional architecture workshop, but I'm not sure if any of us agree on what functional software architecture even means. And that's what I try to do with this website. So if you go to functional-architecture.org/wip.html, so it tells you that this is certainly like a big work in progress at the moment. So if you go there, then you see this website. It says at the beginning, like you can go to this GitHub repository to work on that website. And I invite you to contribute to that. So what is it about? It says functional software architecture, functional programming in the large, and then there's this sentence that you probably read somewhere already. That's from Mike. I just took that and put that on this website. And then I talk about some values that we as a small community, but maybe growing community share, and I'm like, that's what I could come up with, and I hope you agree, or maybe if you disagree, you can go to the GitHub and we can have a discussion. It goes on to principles, something like immutability, pure functions, of course. I could come up with a few more. And then, so idea is that these principles are the ways in which we try to work towards these values up top, right? And to be even more concrete, there's a section called patterns, tools, and techniques where the idea is that we have like a bit of a pattern, a collection of patterns at some later point in time described on this website. So I just wrote down some titles basically, and the text that you see is mostly blind text by now. And one of the patterns here is bidirectional data transformation. So I think that is a pattern, and that now leads me to the actual talk that I'm doing. So for the theoretical foundations of what I'm going to talk about, I'll not go into these too deeply. You can read a paper like the Combinators for Bidirectional Tree Transformations paper, which is quite nice. So motivation, right? You know, like the first sentence on the functional software architecture website is roughly this sentence minus the lenses. So now we want to use lenses in large and long-lived software projects released to real users in industry. So this is an experience report mostly on how we do that at Active Group. And so my focus here is to shine a light on this pattern business. So I think that the bidirectional data transformations pattern, if it is one, has some educational merits in that it showcases some of these principles that you saw on the website quite nicely, such as composition and closure, correctness by construction, everything is a value, purity and immutability, and so on. So the industry that we're talking about, so that the industry that gave rise to this talk is in manufacturing semiconductors, which is a complex process, usually performed in heterogeneous IT infrastructure. And we build one system that has to deal with lots of other systems in the neighborhood. And so there's a lot of data ingress and egress happening there. Yeah, here's a slide on some numbers that I'll not go into much. So that is the project that gave rise to this talk, but I want to discuss the ideas with a much simpler application, which is basically the blueprint of lots of web kind of applications, right? So you have a core domain in the middle. I hope this is large enough now for the people in the back, yeah. You have a core domain, core system in the middle with your domains objects, which are these rectangles, these colored rectangles. And you have some kind of user interface, mostly web user interface these days. Some storage, right, on the bottom here, and then some other service that you depend on. So to focus on so we have a lot of these double-headed arrows here in this picture, right? So there's data going away from our system and also going from an external system back to ours, to our core system. And in the traditional architecture community, for the double-headed arrow on the bottom here, going towards the database system, there were solutions. Let me make it a bit smaller. No, doesn't let me. Such as ORMs, right? So in the beginning, somewhat in the beginning, object relational mappers were created. This has made a lot of people very angry and been widely regarded as a bad move by now. So this is actually, like, in the traditional community, regarded as a bad move also, because like these object relational mappers that try to automatically deal with this persistence story for your domain objects, that brings a lot of problems with it, as you can imagine. So even the traditional architecture community has moved away from that. And so what they now do is looks more something like this, where they have this custom data access layer, sort of on top of the storage system, you could say. And then they write little transformations back and forth to a representation that is like sort of local to this custom data access layer. And this representation, they usually call data transfer objects nowadays. So if you Google that, you will find like a somewhat different notion, because in the beginning, like this is Patterns of Enterprise Application Architecture is like a patterns book for OO patterns by Martin Fowler. That talks about data transfer objects as well, but the original idea was to package up data that you avoid, like doing lots of round trips. That's no longer the main raison d'etre for the pattern. So nowadays you just say that the data transfer object is a separate representation from your core domain, which caters more towards storage, for example. So it caters to serialization and deserialization. So, but now we see, like, in the beginning we had this double-headed arrow at the top, right, the gray one, and then Hibernate, or like these object relational mappers, they wanted to like get rid of this double-headed arrow for you as an implementer, and said, we deal with that, right, no worries. That was a bad idea. So now the current standard is to have this a bit smaller double-headed arrow that you still have to implement yourself. But so it came back, right? The double-headed arrow came back through the back door, sort of. And yeah, and so if you read on in the literature, oh, I think it's just down here. There's a little quote. Sorry. Yeah, so also from the Patterns of Enterprise Application Architecture, there's this little paragraph that says, don't underestimate the cost of using DTOs. So for example, writing these translations. It's significant and it's painful, perhaps second only to the cost and pain of object relational mapping. Right? So it somehow seems to be that the arrow is still quite large. There's still a lot of busy work that you have to do. And there's a similar story for other interfaces as well. So I try to illustrate this with a boundary towards the persistence layer, but also, for example, for the presentation in like a GUI application. You can find things like the presentation model, which is nowadays sometimes called the view model, I think. You can also find a quote, something like that. Probably the most annoying part of presentation model is the synchronization between presentation model and view. It's simple code to write, but I always like to minimize this kind of boring, repetitive code. So now it doesn't explicitly say that it's like busy or tedious to write, because you have to write like these translation into two directions mostly, but that's what I read into this. And I think, yeah, that's a major part for why that's so boring and tedious. So I want to say like one quick word on the merits of this DTO pattern from the object-oriented community, is that it forces you to decouple, right? It's a way to decouple the two systems that talk with each other by saying, well, they don't talk in terms of domain objects, right? That's a bad idea. They talk in terms of a simpler model that is only built for this communication only. So that's good for decoupling. But of course, what happens, since it's a lot of like work to implement these things because of these two-directional arrows that we have, Well, these tend to, like, people call they have objects in their system that are called DTO, but these are then passed around throughout the entire system, like over time. So it degrades, right? The original idea was to have this be a very, very local representation, but nobody wants to do the work of translating that back to another representation, so they're just passed around throughout the system, so everything is sort of voided again. So, and I think that bidirectional data transformations, which is a technique from the functional programming community, can help with this problem. And so I have a little illustration of something like that in Clojure. So the project that, as I said, gave rise to this talk is written in Clojure. So I'll show you what that is about. Yeah, so our example will deal with URLs and links and bookmarks. It's also one of the examples in the original Lenses paper. And we use Clojure, and more specifically, we use a library called Active Clojure, which is developed by Active Group. So it's sort of homegrown, but open source. And we have records, for example. So these are modeled after R6 RS records in Scheme, I think. And they look like this, right? If you want to have a notion of a URL, we define a record type for URLs with a constructor, a predicate, and some accessors. You can ignore the first fields over here on the left. The names on the right denote, or they name accessors for the 4 fields that we have. So there's a protocol, host, port, and path to a URL. And then we can call the constructor to construct the value like this, and we can use the predicate to check if a value is of that type. And we can use the accessors as functions to destructure and get back to the original values. Right, so very simple. And now for the data transfer objects, the idea is that they don't, like in the object-oriented community, the idea is that there's like only data, no logic, which is quite convenient for us functional programmers because we do it that way anyways. But it also has to be like serializable, easily serializable. And we, in our case, use EDN for that. So that's a sort of a subset of Clojure, something like JSON. Like JSON is a subset of JavaScript. EDN is a similar subset of Clojure syntax. So there's something like a map here with the curly braces, and then we use keywords, which is this colon stuff, purple, on my screen at least. Yeah. Color has been fixed. So here for this function that maps a URL to the EDN format, takes in a URL and outputs a map that has a field protocol, host, port, and path, and the values are just the corresponding parts of the record, right? So if we call URL to EDN for our URL1, we get this representation down here. So this is what we just wrote. And now, of course, we need, well, of course, maybe of course, but in our case, we need the other way around as well. So maybe we send that over to a database for persistence, and then at a later point, we want to retrieve URLs. So of course, we need EDN to URL also. And we write that simple function to write, right? We get the EDN, which is a map, and we can access the keys with just by using the keys as functions. And then we call a constructor. So that's simple stuff to do. And there are some examples here. But now, as you can see, like this is the boring, repetitive, tedious work that you have to do. If you want to transform your data in 2 directions, you have to write 2 functions, one might think. But of course, these 2 functions that we wrote, they're not just any functions in our code base that just like casually meet somewhere. They are very like coupled to one another, in that they're, in this case, inverses, and they should be inverses in this case. So maybe there's a technique to deal with that in a better way. Skip that. Yeah, and so the technique that we use to deal with that in a more composable way is lenses. And conveniently enough, the active closure library also provides a lens namespace, which works like that. So there's a yank function, which takes some data as the URL1 and a lens. And we already saw lenses because the record that we defined, the accessors, you could like use them as accessors, as functions that get you the data, but you can also use them as lenses. So in this case, this just gets the URL path from the URL. And this we saw before, right? So this is sort of just a shorthand for yank operation. But if you want to update some URL that you already have, add a path, right? You can also use the URL path accessor as a lens to shove a new value there. So in this case, you end up with functionalarchitecture.org/overview.html, which is not correct, so I update it. I wanted to call this page overview, and then I realized it's work in progress. So that's the website you just saw. Yeah, and there's also a shorthand for shoving, which is there's simple like arity overloading in Clojure. So you can call the URL path as a function with 2 arguments, and that is basically doing a shove. So this line right here is a shorthand for this line, you could say. So records in themselves like give you lenses, but that's not enough. We also have like lens combinator or lens constructors for the usual Clojure data structures, such as a vector, which is literally written like this. You can call lens at index 1, for example, to get a lens that points to this 42 in this case. So if you yank from that, you get the 42. And for maps, which are like often used in Clojure, associative maps, you can use lens member with a keyword in this example, and then that points to the 23. And then I wanted to, like in the beginning I said that this shines a light on some of the principles of functional software architecture, such as composition, right? So of course I have to talk about combinators for lenses. So here's one, sequential composition, written with this greater than thing. So in this case, this takes 2 lenses to first look at the A part. Now I just showed you that lens member creates a lens pointing at a keyword. You can also use keywords right away as a corresponding lens, also a shorthand. And at that value, I want to look at the 3rd position in this case, so that if I yank with that lens, then I get a 69 here. There's also other combinators that are not going to. And then there's also projection. So often we have, like the Clojure community likes to use ad hoc modeling with vectors, for example, or these maps that we saw. So if we want to represent a quote, for example, we could use this tuple vector syntax, where there's an author in the 1st position and a text in the 2nd position. Or another representation would be a map with an author key and a text key. Right? And they mean the same thing, they're just different representations, so there should be a bidirectional transformation between the 2, and we can use project, the lens project constructor for that. So that takes a map, but that's just syntax, where you list the output lenses mapping to the input lenses. So here we want to map author to at index 0 and text to at index 1. And so now if we yank from this representation, so the vector representation of a quote, with quote vector to map, we get the map representation. And the other way around you can do with shove. Now here's a bit of a problem because we don't know where to shove into, right? So the Foster paper calls this the missing value. We have to provide this here, just as like a dummy thing. And then we can shove with this lens that we defined, and that's the data we want to translate, and that gives us back the vector representation. And then finally, well, not finally, but now we get to inverting projections. So instead of calling shove with this dummy value, we can also invert the quote vector to map lens and then provide the dummy, empty, missing value here. And that gives us a lens where we can yank from this map representation, and it gives us the vector representation. just as we did with shelf before. And since we're dealing a lot with these records, we also build a shorthand for record projections. So this is the same definition that you saw before for the URLs, but this line is new. It says projection lens constructor make URL lens. So this gives a name to a nice little utility where you can easily make projection lenses with. So it works like this. Down here we can also define this EDN to URL thing that we saw before as a function. Now we can define it as a lens by calling make URL lens, and then we just, for these fields in turn, we provide the lenses in the corresponding to the input structure. So and now EDN to URL, before it was a function, now it is a lens, so we can get the inverse direction for free by calling invert, for example, here. So we don't have to write this tedious, repetitive, error-prone code anymore. Right, so that's the basic idea. And to build on that, we go on to define a record for links, which is a link is just some URL with a description. And, well, of course, we also want to have links be transformable into EDN notation. So we also make a projection lens constructor for that and build an EDN to link lens with the help of that. So here we say this description is a string that just maps to the corresponding field in the map, but the URL part, now we have to use lens composition to, well, first of all, get to the URL value in the corresponding map, and then this we defined before, right? So here we can compose, and then we don't have to alter what we wrote before, which can just reuse without loss. Now there's also a story in dealing with mixed data. So if we have a folder structure which has a name and some bookmarks. Now what is a bookmark? A bookmark is either a folder or a link. So this is a recursive data structure. And this already tells us, well, we're dealing with mixed data, right? So there has to be something in the lens realm as well for that. And well, we do that with a bit more involved code. So first of all, we have to forward declare EDN to folder because we'll have to tie the knot here later. And then just to show this once, we could have done this differently, but I wanted to show how, like, the lenses that we use, I said you can use them as functions with either arity1 or arity2. Well, you can also define them that way, right? So this is, oh, this is wrong. This is def. So this, oh, no. No, it's not wrong. So this defines a new lens combinator untagged, which takes a tag and a lens and sort of wraps the given lens with this tag. And you can you define a lens with just a lambda with two arities. So this is arity1, takes an x and then does some things that are not interesting. Or it, like with arity2, it takes an x and a y, and that corresponds to the shoving, like shoving y into x. Right, so here it associates a tag with it, and here it unassociates it. And we have a little helper tagged as, which is just a simple predicate. And then EDN to bookmark uses lens conditional, which is another lens combinator you could say. Takes some clauses, and each clause consists of 3 parts: a predicate on the input structure, a predicate on the output structure, and a lens. So in this case, we ask if we have a tag, like is it tagged as a link, our map, our EDN structure, that is the predicate for the input structure. Is it a link question mark, so that's our predicate for the link record. And if that's the case, either way, we use this lens, so the untagged link, EDN to link lens. And similarly for folders, right? So, but here we need to use lens defer because EDN to folder is not defined yet. So we forward declare that at the top. And EDN to folder is now just make folder lens, which is again the record projection lens constructor, you could say. The name just maps to the name keyword, and the bookmarks maps to the bookmarks, but then we need to map over those bookmarks. So we use map lens, with the EDN to bookmark defined above. yeah, so that's the brief introduction and how that works in our closure projects. And now I'll move into the more free-form discussion part of the talk. So I have something prepared for that, but I really would like to invite you to like interrupt me at any time if you think something's wrong or missing. And that part is what makes this a pattern, right? I was talking about patterns a lot. I think last year Will Crichton also talked about, like, had a little discussion for the audience to come up with patterns and what it means to be a pattern and so on. And so I have 2 bullets here, which I hope are large enough, probably not. Which is that I think it splits into 2 parts. Lenses and their combinators can live in libraries. I mean, we saw an instance of that, and there are, of course, lens libraries for Haskell and OCaml and so on as well. But the heuristics of when and where to apply them for these bidirectional data transformations cannot live in libraries, right? You have to bring like an actual human thought into that. And that's, I think, the harder part, right? So you can write a library and verify that it's correct once, but then when to apply it is the real question. And the first part is when to reach for this pattern. Again, a quote by Martin Fowler. He also thinks about this, right? When is the DTO pattern the right thing to do? And he says some stuff, but not really a lot, right? So we cannot really find any insight there, I think. At least I didn't find anything. So we have to think ourselves. And I think the general framework is always this. You have some other system and you have some your system, and there's at least like 2 like data flow going up and down, right? So that's the bare minimum. If you don't have this, then you don't have to think about it, I think, in terms of bidirectional data transformations. But then, like, so this pattern is applicable, I would say, if the same kind of data or the same shape of data moves up and down in this case. But what does that mean? I could come up with like 3 scenarios. Either the external API, so the API for the other system, explicitly tells you that that is the case, right? So it might be like an API description of some REST API, where it says, well, the shape you get from this endpoint, you can post to another endpoint. It's definitely the same thing that moves in both directions here. But that's very seldomly the case, at least in my experience, that these guarantees are stated explicitly. But maybe they're stated implicitly, so lots of systems give you places to read from and write to, and they like guarantee that they don't touch what's there. We could call this a payload, right? So in the persistence instance, we could talk to a database and write like a serialized JSON or EDN string to some field in some column, and we can be pretty sure that the shape of data that we put there is the shape that we read at a later point. Well, or you just own the other system, so that makes it easy for you to just enforce this guarantee. Or maybe you don't own it directly, but maybe it's in the same building or same company or something like that. So, but this framework where you have some other system and your system, I mean, I wrote down system, but really there's nothing specific to this having to be like full-blown applications that talk to each other. I think earlier in the day, Mike was telling us something about a modulith, right? So people in the traditional architecture community tend to realize that a monolith doesn't have to be unmodular. So you could easily think about this inside of your application as a communication between modules. And to give you a little taste of what that looks like in our daily work is that we use our own library for user interfaces, for component-based GUIs. And there we realized it took a while, but we realized that the relationship between parent components and child components is often lens-shaped, as in this example. So if we were to write a GUI for our folder link URL business that we saw before, it would probably be structured something like this, where we have a folder component, and that is made up of a component for the folder name, which is just a simple string input, and a component for the folder bookmarks, call it bookmarks component, and that in turn uses bookmark component and so on. So that decomposes further. And now the relationship between, for example, the folder component and the string input is exactly that of a lens, because like the string input has to show the string, so the name of the folder. So that's like a yank. So you have to yank out that string from the folder structure. So folder component manages a folder record, as we saw before. So you have to yank out that folder name to give it to the string input. But then also the user just doesn't just want to look at the folder name. They will also want to manipulate it. So they type something else, and that is like the shove back, like a new string is shoved back into the folder component. Right, so in our GUI applications, they often look like this. So this is real code, where we have a component combinator library, you could say, and one of the combinators for components is focus. So up here, test editor is an item. We call them items, so you can also call them components. And then elements input is one of these simple inputs, right? And the relationship between this test editor and the input is described by this lens. So this is a lens in this case. So that's what focus does, right? And we have another focus down here for some SAP endpoint thing, and another focus for some edit requests component, and I think another one down here. Right. Oh. Wow. No. Okay. Yeah, so I talked about when to reach for this pattern, but this isn't like you could say all the time. But it's also important to talk about when not to reach for this pattern, because, well, one instance where I think you have to be careful is when the structures that move up and the structures that move down, they may be accidentally the same, right? Or you could say momentarily the same, but they are not, their meanings aren't the same, right? So you have to be very careful that there might be a subtle difference in the meanings of these structures. For example, in this booking case, so we have an application where you can book a flight, for example. You might think that, well, or it might be the case that at some point during the life cycle of your application, the data that a user sends to our system might look like this, right? And you call it a booking because it has a booking flight number, flight date, and a seat. So the user requests a booking for a flight this way. And then the system at a later point confirms that booking, and what they send back, or what the system sends back to the user is also shaped this way. So you might say it's also a booking, also contains a flight number, flight date, and a seat. But that is just one snapshot in the evolution of the system, because what's really going on here is that the meanings of the thing that moves from the user to the system is different from the meaning that what the system is sending to the user, because one is like a request to, like what did I call it, a booking command, right? So at a later point you might end up with something like this, that the user sends a booking command to the system, and the system sends a booked event maybe to the user. And you might only realize this when they are drifting apart, right? So booking command maybe has not a definitive seat associated with it, but maybe just a preferred seating, window, aisle, or whatever. And then booked event, now that has to talk about a specific seat, like 23F here or something. And I think it's like, you have to be very careful not to like cling to this bidirectional data transformation. So if you at one point write a bidirectional data transformation for a booking, you might not see that they're actually not the same, and you might not end up with pulling them apart at a later point in time. Right. But there are maybe other cases where you can fall into pitfalls. So that concludes like the stuff that I have prepared, but I really like to invite you to come up with some scenarios and ask questions.
I'm going to use moderator's privilege to say this it's very interesting to hear bidirectional transformations talked about now as something that came out of the functional programming community, because it really didn't. It goes back way, way before that. Yeah, I've got a collection of questions. I'm not quite sure how to ask them. Could you say something about the relationship between the way you think about bidirectional transformations for architecture here and the way that, for example, the object management group's original concept of bidirectional transformations as part to support their model-driven architecture came to be? And
I don't know anything about that.
Okay, we should maybe talk about this offline. So, a sort of potted history. You put up the paper that came out of Nate Foster's PhD right at the beginning. So that was sort of the functional programming beginning of lenses. But the interesting thing that was happening at the same time was that the object management group was realizing that it needed bidirectional transformations in an object-oriented concept. And so the bidirectional transformation community came out of the conjunction of those two things, both happening in about 2006, 2007. And it's very interesting to see, because in between there's been all this sort of functional programming work which has not been very architectural, which has been focused on the combinators and the small-scale programming. So I end up feeling very old and feeling as though things have now gone full circle, because now here you are talking about lenses for architecture again, which in my conception of history is where it came from in the first place.
But is it like in industry, is it like used in the object-oriented community? At least what I see, it's not.
No. So that's the interesting thing. So the OMG effort got mired in a whole bunch of problems that the functional programming community is very good at solving, at precise semantics and understanding exactly what these things should mean. But there's lots more to be done to tie these things up, I think. So yeah, good stuff. Let's do lots more. But there is a lot of history that you might find really interesting to look at, and a lot of other papers out of that world. Maybe I could advertise the BX community wiki, which is not terribly active these days but still exists. bx-community.wikidot.com.
Should I open that?
I did check that it was still up.
BX wiki?
No, BX-community.
Community.
.wikidot. No, wikidot, all one word.
Oh, wikidot.
.com. Yeah. There you go.
I see.
The BX wiki. So that's one place to start.
Yeah, I saw that there was a Dagstuhl where you were happening in 26 or.
Yeah, that's right. Yeah.
Around that time. So that was already bringing together these communities, or was that?
Yeah.
Okay.
So lots of interesting stuff going on. Yeah. So what would everybody?
Could you maybe contrast? I mean, were there notable differences between the way that the model-driven architecture community approached this?
Absolutely, very different. So one thing I'm going to end up kind of improvising my own talk kind of thing, but one thing I'd like to make the case for actually is you said reach for lenses where the same data goes up and down. The way I think about it would much more be reach for lenses when there are two things that need to be kept consistent, for some notion of consistency, because that's a bit more general. Because sometimes the data, so you can always cast it as the same as some notion of the same data or parts of the same data going up and down. But sometimes it can be quite heavily disguised if you're picking out bits of data from one place and bits from the other, and the formats are quite different. It might not look like the same data when you first look at the problem. But there's always a notion of consistency. You've got a notion of saying, if this one is like that and that one is like that, are they okay? Are they consistent with one another, yes or no? And then a bidirectional transformation is a thing that has two jobs. One is to say, check whether they're consistent, and the other is to say, if they're not consistent, then bring them into consistency by modifying either one or the other. Lenses is a special case where one end has strictly more data than the other. And in that case, you call it yank, don't you, not get, enclosure. Your yank is the thing that will bring the smaller amount of data into consistency, and your shove, or in the original conception, put, is the thing which will bring the two into consistency by modifying the larger collection of data. That's always the harder problem, because you might then have to, invent stuff that's not present in the smaller data.
Yeah, unsurprisingly, these names were taken.
Yeah. We always get this. So one of the things that the object-oriented BX community went kind of round and round about was the fact that, in general, a bidirectional transformation doesn't have to have that property, where one end of it will have all of the data. It might be that you've got two ends, and each of them has some data which is not contained in the other. And the classic example from the OMG standard is UML to RDBMS, which is the horrible problem reinvented, where you can say, well, okay, your UML model will have all kinds of information that's completely irrelevant to your RDBMS, and the RDBMS may have indexes and something that the UML knows nothing about. In the end, people have, there are all kinds of category theory papers and what have you that talk about how actually, you can always construct all of these for a certain class of things out of pairs of lenses, and you can do it in various different ways, and you can tie yourself up in knots like that. But then the question is, how do you actually want to program? So for a long time, there has been a wish to be able to program those general books, so to be able to write your programs under the assumption that you're going to be dealing directly with things, neither of which is an abstraction of the other. And we don't have good languages for doing that, really. And when you start thinking about the properties of those things, you quite quickly tie yourself in knots, because you find out that you can easily write down properties that you would like, and you can demonstrate that you can't have them. Things become a lot easier when you stick to lenses. And actually, pragmatically, that's probably the right thing to do. And back in sort of 2006, 2007, when people were thinking about it, one of the reasons for not thinking about it that way was the unreliability of the internet. Because the obvious way to solve this problem is to say, well, what you'll do is all the data you might ever be interested in should live in one place, and then everything else should be projections of that. And the point at which that went wrong was you said, well, you might not be able to connect to that place that's got all the data. And so then you might want to be able to do these sort of two-way connections between things which are symmetrically connected. And these days we sort of don't really believe in that problem anymore, because the internet is reliable enough that you can just say, well, you'll be online, or you'll be online soon enough. But
there's also the issue of administrative boundaries. So you may not want
yes.
to have everything in just one place, because
yes.
you don't switch possibly.
Yes, absolutely. Yeah.
Thanks. Didn't point me to a few papers. Or maybe I could just read this website. Is that enough?
Yeah, the website is a bit partial and not very up to date. So I think the last few years, I was part of a research project that was one of the contributors to it in the early days, but that's going back 10 years or so now, and more recently I don't think anybody's been very systematically updating it. So there'll be some good starting points there, but it's not up to date or comprehensive at all, and it's probably gives a rather partial view. One of the things that maybe is worth looking at, if you scroll down, there should be a link to, try the BX examples repository. And do consider contributing to that, because that's got quite a lot of interesting, or potentially interesting, examples from a number of different sources of bidirectional transformations that people have worked on and formalized in various different ways, or not formalized in various different cases. Yeah, so one of the motivations for this was to think about the different properties that you might or might not want bidirectional transformations to have. So correct and Hippocratic is Book's language speak for get put and put get between them. It comes to the same thing. Undoability and history ignorance are among the properties that you often would like to have and don't, and correspond loosely to put, so that, there's some discussion down here. Mike Johnson is one of the people who's done a lot of work on that. Right.
Thank you.
become
The-
your talk now.
No, that's